Welcome everyone, and thank you for joining our October Weiler Wednesday webinar. My name's Chad Honstein. I'm the Creative Services Manager at Weiler Abrasives. Today I'm joined by Tony Hufford, our Category Manager for Metal Fabrication, and he's going to talk to you about proper selection and safe use of chopped, gas, and stationary saw cutting wheels. Before I begin, I just want to share a few tips on the Zoom platform. First, we've muted all lines to prevent background noise. About midway through the presentation, we're going to have a contest to give away a prize. We'll ask a question, and you could submit your answer using the chat function. If you have questions at any time, feel free to use the Q&A function, and we'll answer those at the end of the webinar. And finally, you should see two polls pop up throughout the presentation. We invite you to participate by choosing the answer that best relates to you. Next slide, please. Before we jump into the presentation, just a couple quick updates as it relates to our response to COVID. We continue to manufacture around the globe to help critical industries that need our products through these challenging times. As we get back into the field, I just want to share some of what our field sales team is doing to engage customers and distributor partners. We're doing that virtually, just like we're doing today, and we're conducting virtual training events like spot safety training and troubleshooting applications to provide solutions to our customers. We're also back in the field in many areas where it's safe. We're following local and CDC guidelines related to social distancing. We're wearing masks and sanitizing to make sure that we stay safe and that we're coming to your facilities in a safe way. Please don't hesitate to reach out to us. We can accommodate your needs as they relate to abrasives, and we can do that remotely, or we can do that in person at your facility. So with that said, I'm going to hand it off to Tony now.
Good day, everyone. My name is Tony Hufford. Thank you for joining. Our agenda today, we're going to have a quick safety overview. We're going to talk about understanding the tools that really relate to these larger diameter cutting wheels. I'm going to talk to choosing the appropriate cutting wheel and then maximizing the performance of that cutting wheel as we move forward. But before we begin, just talk a brief bit about safety. It certainly begins with all of us. Safety's taken on new meanings during the pandemic and different times, but we always want to leave the workplace the same way we enter it. We want to be safe with our protective equipment, our gear. And Weiler conducts SPOT training. SPOT is an acronym that stands for speed, size, pressure, orientation, and time. And that can be conducted in person and certainly virtually. And regardless of what we're doing, I like to say, if you spot someone doing something safely, recognize them for it, right? Encourage them with it. And if you spot someone doing something unsafely, help them out and give them some advice. We all want to make sure we're safe in doing the jobs that we love. So in moving to that and understanding the tools, it's really important to have high performance products. It's critical that we understand the tools and how we utilize them and how products fit on these tools and how to recommend the right products for the right tools. So as we move forward, we're going to start with chop saws. A lot of people are familiar with chop saws. I love them. They're light, compact, really portable, carrying them around where you need them. Those are some of the really big benefits to these saws, easy setup, easy to operate. Some of the challenges you have are just making sure you're clamping everything properly, that everything is on a flat surface, and they are lower power tools. So while it's not necessarily unsafe to use some cutting wheels on them, you certainly don't maximize your performance, and it creates a lot of challenges if you don't use the right cutting wheel for this product. And that brings me to our first safety spotlight. We want to make sure we're avoiding excess pressure. Just in my personal life, as I've used these, it becomes very challenging if you don't have the right product to cut for the right application, and you tend to see glazing, you tend to see a wheel just sitting on the edge, and you really want to use more pressure. Not necessarily a good thing, you're going to create challenges. There's challenges with slippage, and you're going to create challenges with tripping breakers as well, which becomes an annoyance and a safety factor in itself. And you never want to over tighten these wheels too much. So you want to make sure they're clamped properly, but not over tightened. You don't want to create any micro fractures or cracks in these wheels, and you want to resist the urge to push too hard. If you're using a wheel and you're pushing hard constantly to get them to cut, you have to consider that you're not using the right wheel for the right application. As we move forward, stationary saws, I consider these, chop saws on steroids. They have a really high power, high torque. They're very stable and serviceable and fixed mounted. So it gives you a really good wheel that's not going to bog down. You're not going to bog down this tool as you're cutting through. Some of the challenges you run into is that lack of portability, certainly the space that's required. And one of the things that's critically important is that you're mounting the products appropriately, because this wheel isn't going to stop. It's going to drive right through the piece you're cutting. And if it is not mounted properly, it's going to accentuate that and really cause a safety factor. So it's something you really want to pay attention to. And finally, gas saw wheels, real popular, real common. They've got increased power. They're highly portable. You're carrying them around with you. You're taking the tool to the workpiece instead of the workpiece to the tool. And really tough, built to operate, built to last for a long time. Some of the challenges is the maintenance that you have. I think of starting a gas saw like I think of starting my weed whacker at home, my gas weed whacker. It creates some challenges sometimes, especially with cold starting or other pieces like that. And you've got a higher noise level, but these products are designed to be portable, powerful, and really get the job done for all your cutting applications. And it brings us to our second safety spotlight, which I personally have heard a lot of confusion out in the marketplace from the standpoint of, well, the wheel fits my tool, it fits under the guard, so it's safe to use for that product. While that may be true for a 4.5-inch angle grinder or a 7-inch angle grinder, where you have the product, it fits on the arbor, it fits under the guard, and you can use that safely on that tool because it matches the RPMs. That's not the case with these higher power wheels. You can get a wheel that fits under the guard, that fits on the arbor, and it's very unsafe to use on this wheel just due to side loading or how much that's reinforced. So don't just assume because it fits, it's safe. Really take a look at that RPM, and you can see I have it highlighted here. You want to make sure you're matching the RPM with the tool, because that's telling you that this product is produced and reinforced to work with that tool and to work with any type of side loading action that you're going to see. So that's the tools in the nutshell. Let's move on to really choosing the right wheel. And we're going to talk about some configurations and maybe some things you didn't think about as far as how these wheels are constructed and how that construction leads to the design and application and proper use of these wheels. So from that standpoint, let's just identify the applications. When I think about applications, I think about multiple consistent cut lengths of material, higher cut capacity, 90-degree cutting, these portable fast cuts that we just talked about with the gas saws. And there's certainly a lot of common NAICS industries that they're used on. The North American Industry Classification System, which is really grouping common industries, but anywhere from fabricating metal, shipbuilding and repair. One of my personal favorites, travel trailer and camper manufacturing. So the structural steel on those, really common applications for these consistent multiple cuts that people are making. And as we look at the cutting wheel tiers that I'm going to talk about, Weiler has multiple tiers of performance. When we talk about the high performance line of large diameter cutting wheels, we're going to be talking about rail wheels specific for high demanding applications. Our high performance line of Tiger aluminum oxide wheels is going to fall into our gas saw range, our high speed range, and all of our chop and stationary range. And then we do have a value line of Wolverine, which is professional line that falls in our chop and stationary wheels. And I'm going to go through each one of these and how they're configured. So as we look at choosing the right wheel for specialty chop saws, some of the things I've noticed in the marketplace is people aren't necessarily identifying the supports or especially the fiberglass that you see in wheels. So as we work through this, I'm going to talk about that in a minute, but fiberglass or glass are the bones or structure of these wheels. They don't do any cutting, and quite frankly, they get in the way of a lot of cutting that you do, but they do hold the products together. They're necessary for safety, and they're necessary for certain applications require different structural configurations of fiberglass. But as we move left to right, we've got wheels specialty for stud cutting. 2 layers of fiberglass is a standard, and we're going to show you what that looks like in a minute. But for primarily all of the large cutting wheels that you use, you'll see a 2-layer fiberglass piece. These are specifically designed for cutting that thin metal and doing accurate cutting. Certainly for stud cutting, you want accurate cutting. The single layer reinforcement, so this is the first time we're calling out, and this is an original. You don't see reinforcement called out on these wheels at all, and it's really hard for users to tell. And this gives people an extra sense of confidence that I'm using the right product structurally for the right application. Not only is it going to perform well, but it's going to be safe as well. So that single layer of fiberglass is in the center. It really adds for fast cutting, action, and burr reduction because you're eliminating some of the fiberglass that slows it down. High performance and smooth cutting, both 2-layer fiberglass pieces. Whether you have specialty coated grain, softer bonds, there's a lot more than just fiberglass and grain that determines how these cut. There's different products, additives that we use, coated grains or different specific grains that we use, and bonds or resinoid bonds that we use to make sure we get the right combination for the right application. So those are 4 specialty products that are really highly specific for applications, but can be used for other applications as well if you want to use them across the board for general applications, if you have a primary stud cutting and have others to do. From a high-speed saw, we've got specialty rail and triple reinforcement. So from a rail cutting standpoint, you can see that rail, and when you're using that, you're mounted to the workpiece. You're cutting straight lines on really high hardened reinforced steel. From that 2-layer fiberglass standpoint, you're not going to get any side load from that application. From a 3-layer or triple reinforcement wheel, that's made for high-speed gas saws as well. More freestanding, high-speed, increased side load, and really designed for the highest RPM tools available. So not only matching up that RPM, but matching up that reinforcement gives that user the extra confidence they're using the right wheel for the application and using it safely. Talked a lot about construction, so we're going to get into that a little bit now. As you look to your left, you can see a 2-layer, what we call 2-layer or standard fiberglass. So that's 2 layers of fiberglass on the outside depicted by the yellow dotted lines, or a single layer. That's a center layer of fiberglass in between. On the single layer piece, you can't see the fiberglass, but you can see really the pattern difference between these two. So as you look to your far left, you can see a grid pattern of that fiberglass. And it's really a smooth abrasive pattern that you see on the single layer wheel. And that's an easy way really to determine quickly the reinforcement on these wheels. As we look at that single layer reinforcement, there's more abrasive material, so you get faster cutting and you get a smoother cut. There's less resistance to vibration and less resistance to overpressure. So you want to make sure you're using the right product with the right wheel. You're not using it on a super thick type material, cutting through and getting that fast action. When we move on to 3-layer or triple layer and double layer fiberglass, you can see as I go to the left, that triple layer reinforcement just combines what we just talked about. So it's got 2 layers of fiberglass on the outside, 1 layer of fiberglass in the center. You can see to the far right that double layer of fiberglass that we were talking about. These are a little bit harder to distinguish. That's why we don't have the flat version showing to you now. You'd see that same grid pattern that you saw with the double layer. So that's one of the unique things Weiler done is actually put it on the blotter so the user knows what this product's made of, how it's made, and they can get that extra level of confidence that they're using the right wheel and using it safely. So from this 2-layer and 3-layer construction, they're made for high power wheels. They incorporate in some of the higher grains that need a little bit more pressure, like a zirconia alumina. They're designed for these higher RPM wheels, high performance applications like rail cut. And they introduce a new arbor, a 20mm arbor versus a 1-inch arbor. This is where we get into the factor of safety versus efficiency. You can run these wheels on a chop saw with a 1-inch arbor. They'll fit, they're safe. but they won't run well because of that low power saw won't be able to break down some of this fiberglass and these thicker wheels that you want to use. So it's a really combination of being safe and also being efficient with the wheels that you choose. And then moving to stationary saws, we talked about that high power, that high torque. So we've got a thicker wheel construction here. Typically you see a 3/32 or similar size wheel for chop saws. You'll see a 1/8 inch wheel for stationary saws. You've got more abrasive grain on the wheel, 2 layers of reinforcement that allows for that wheel to be driven through, and a lot of abrasive grain doing the cutting. Again, that increased thickness is designed for higher torque. You've got increased diameters available because it is thicker, it's more stable. And we've got some fast cutting design as well in the Wolverine, so that ties right into the product that we talked about. It's not going to run well on chop saw again. It'll run safely, but it's not going to be efficient because you got to break it down. It's a little thicker and it's going to create more friction, more material that you need to cut. So again, it's a question of efficiency versus safety on these wheels. So I'm going to pause for a moment. As we talk about this, please enter in your response in the chat section, and the first person to enter their response is going to win this power pack. I've got one myself. There's 2 slots. You can charge 2 phones at once, and one of these packs will charge your phone about 4 or 5 times. So name one of the 4 specialty chop saw wheels I spoke about, and also include one feature of that wheel. So name one of the 4 specialty chop saw cutting wheels and one feature of that wheel. And as we move on, we're going to talk about maximizing wheel performance. So we talked about wheel safety. We've talked about how these wheels are configured. Now we're going to talk about how to mount the workpiece to make sure we're maximizing our performance and also cutting safely. So as we work through this, you can see 3 orientations of angle iron. Angle iron is a very popular material to cut with a chop saw. And you can see that we have 3 orientations here: that straight, flush, or pyramidal type cutting on the left-hand side. You've got it shaped in an L miter in the center. And then we've got a safety concern on the right-hand side. You can see there's a very small area to be mounted, and also some concern that we may not mount that properly or consistently all the time and have some movement when we're using the wheel. So we want to always firmly clamp that workpiece to minimize vibration. As you create excess vibration, you're going to create excess wear on these wheels. We're going to orient the workpiece so it enters in at the narrowest point of contact. You can sort of see that from left to right as we work through a narrow, narrow, and then thick entry. As the arrows pop up, you can see when a chop saw comes down, it doesn't go straight up and down, right? It comes down and swings in. So as we do that, we want to make sure the point of contact is at the center line or slightly behind the wheel, so we cut through and pull right through that wheel efficiently. Using even and consistent pressure. And then starting on a wide flat surface can cause glazing, especially with thicker materials. I'm going to show you in a minute how it works with some thinner materials, but it's just something to keep in mind. Not always a safety concern, but really maximizing the performance and giving you some different options to try as you're using these wheels. As you look to the top, less efficient versus more efficient cutting, that's the same exact square tube. And as you're looking at that square, the less efficient way, we just talked about utilizing that full surface area, coming in contact with that full surface area as you cut. And the more efficient way is getting that angle of cut, hitting that sharper point, if you will, and pulling that product down through that wheel. The workpiece orientation or other profiles, listen, sometimes you can't control how you want to cut these things or how you have to orient them. And certainly as you're using a round bar, there really is no starting point. You just want to make sure you're leveraging in on that center or slightly behind the center line. From an I-beam standpoint, it makes sense really to cut both of them at the same time, right? The edges hitting that smaller point of contact and be able to pull that wheel through, but you're inevitably going to hit a thicker point of contact through that cut. And then from the standpoint of stud cutting, you don't want to bend, manipulate, or create any issues with stud cutting. So cutting them at that flat surface with that thinner piece is often the best way to go. And I see we've got a pop-up now from a material standpoint. We really like to know just what types of material you're cutting most frequently. And as we look at that, there's different profiles you're cutting as well. So the point of this is if you can be efficient and it allows for it and you have options, you certainly want to cut from a point slightly behind the center line to be most efficient. Sometimes workpiece orientations or these profiles create necessities to still work safely and to make sure we're not deforming the part when we're cutting it. And just to wrap it up, we want to make sure it's safety first always, like we talked about from the beginning. We're going to choose the right wheel for the application. If we find ourselves having to press too hard or we see it's not cutting, oftentimes it may not be the right wheel for the right application, even though it's a safe wheel for that application. Always want to make sure we're clamping and orienting properly, like we said, from the wheel. We don't want to over tighten these wheels, these resinoid bonded wheels. We don't want to create any stress fractures on them. And we want to always secure not only both the saw, but the workpiece as well to minimize that vibration. From a productivity standpoint, pushing harder is not always going to cut faster. In essence, a lot of times it's just going to create a lot of wear and tear on you personally, and you're not going to get a lot of more work done. Entering the workpiece at that thinnest point, if possible, like we spoke about. Don't use 1/8 inch wheels on chop saws. That could be a gas saw wheel. It could be a stationary saw wheel. They'll work, they're safe, but they're not efficient. And you want to let the wheel do the work. And if you're going to let the wheel do the work, that's choosing the right wheel for the right application, for the right material. And it's going to allow that wheel to really pull through that workpiece and do accurate, clean cuts. And as we look at this from a next step standpoint, we're going to be sending a follow-up email this week and several resources to help and guide you through this. We've got a product flyer that highlights all of our cutting wheels from chop, high speed, and stationary saws. Our bonded brochure that's going to cover our full line and how this incorporates into that full line. We've got a cool promo where end users could win an Echo Dot. I've got a couple of them in my house. They're very cool, very easy to use. Very convenient, actually, for turning on my lights. But when you buy $500 in Weiler abrasives, you're going to get that Echo Dot. And then a case study that really highlights the rail wheels. We're really happy with the way this program turned out, and we really want to get this information to you so that you're not only choosing Weiler, but you're choosing the right Weiler product to use on the right wheel with the right material and application. And then from webinars you don't want to miss, we've got Rick Hopkins, who I know personally, and he certainly knows abrasives. And I'm psyched about this format because he's going to be hosting this webinar and having conversations with weld.com. You can see Mike and Jason there. So from that standpoint, there's a lot to learn about improving the quality of multi-pass welds, but they're also going to talk about what happens if you don't clean properly, which I think is really going to help a lot of people in the industries understand just not only the performance and maximizing performance of these brushes and abrasives, but if you don't do that, what are the consequences that you see? So I'm really excited about how cool this presentation is going to be, and stay tuned for additional innovations that we bring.